1.1d is on solving one variable inequalities. This is going to be very similar to solving equations. It's just they are inequalities instead of equations. So solving inequalities, let's take a little bit of time and compare our equalities or our equations to our inequalities. So an equality, it has an equal sign. So x equals 2 as an equality. In this situation, the only possible solution is 2. So if we were going to graph this, it would just be 2 on a number line. That is our only solution for this problem. In an inequality, the solution, so we have x is less than 2. The solution is all real numbers that are less than 2. So here's 2 on our number line. But 2 isn't actually a solution, so I'm going to put this open circle. But it says all real numbers less than 2. Well, 1 is less than 2, 0 is less than 2, -1 is less than 2, and on and on and on to negative infinity. So I am going to draw an arrow, and here's our graph signifying that 2 is not a solution, but every number less than 2 is a solution to this inequality. So inequalities, there are 4 different inequalities. Number 1, we have greater than, so 10 is greater than 6. Number 2, less than, 4 is less than 17. Then we have less than or equal to for number 3. Well, 5 is less than or equal to 6. 6 is less than or equal to 6. And then last but not least, we have greater than or equal to. So, for example, 4 is greater than or equal to -1, and -1 is greater than or equal to -1. These are our 4 different inequality signs that we'll be working with. These are the 4 different inequality signs that exist. Let's look at a couple real-life examples. So when you are driving, if you see a speed limit sign, your speed x, it has to be less than 50, but it could be equal to 50. So your speed could be is represented by x is less than or equal to 50. We could also flip this around and we could say, well, 50 is greater than or equal to your speed x. These mean the same thing, they are just flipped around. Have you ever gone on a carnival ride and it tells you you must be a certain height? So this sign says you have to be 52 inches tall. So that means your height x could be greater than 52, or it could be equal to 52. And again, we could flip this around. 52 could be less than or equal to your height x. So these are some real-world situations where you might encounter inequalities. Solving equalities and inequalities are very, very similar. So in both, you're going to isolate the variable using inverse operations. Okay, you're going to isolate the variable using inverse operations in both of these. Really, the only difference is that in an inequality, you have an inequality sign. So for this particular problem, we've got this less than sign instead of an equal sign. The major difference is that when you multiply or divide by a negative number, your sign will flip. So for example, if we have a less than sign, if we were to multiply or divide when we were solving our inequality, the sign would flip and become a greater than sign. Let's look at a couple of examples. So we want to solve and graph the solution to each of the following. So number 1, we have x plus 4 is less than 13. Well, we just want to isolate x. So we're going to go through and use our inverse operations to isolate x. Here we have x plus 4. Well, the opposite of adding 4 is subtracting 4. So we have x, this eliminates to 0. 13 minus 4 is 9. And then since this is a less than sign, we keep that. So now that x is isolated, we know that for this problem, any solution or any value that is less than 9 will work for this inequality. So to graph this, I'm going to put 9 on my number line. Since it's not equal to, we're going to have an open circle. If it is equal to, we'd have a closed circle. And then since we want all the numbers less than, that means 8, 7, 6, so on and so forth. So our arrow is going to be going towards the left. Okay. Number 2, x minus 7 is greater than or equal to 21. Well, again, we just want to solve this. So we're going to add 7 to both sides. Well, we have x. This eliminates to 0. We keep our greater than or equal to sign. 21 plus 7 is 28. So x could be any number that is greater than or equal to 28. So I'm going to put 28 on my number line. 28 could be a solution, so I'm going to put a closed circle. And then anything greater than that would be like 29, 30, 31. So I'm going to draw my arrow to the right. Number 3, we want to write an inequality for the given graph. Well, our circle is on 5, so we know that we need an x in our inequality, and 5 is going to be in our inequality. Right? Whatever number your circle is on, that's the number that you use in your inequality as you are writing it. Since it's an open circle, we know that it's going to be strictly greater than or strictly less than. Well, our arrow is going to the right, and let's see, 6 is what then 5? 6 is greater than 5, so that tells us for this particular problem, x can be any value greater than 5, and that would be our answer. So these are all examples of inequalities. Let's look at a couple more. Now would be a good time to pause and see if you can solve for yourself. So number 4, we have 5x is greater than negative 20. Well, we have 5 times x. So the opposite of multiplying by multiplying by 5 is dividing by 5. So let's divide by 5 on both sides. 5 divided by 5 is just 1. So we have x. We bring down our greater than sign. Well, is greater than negative 20 divided by 5 would be negative 4. So x is greater than negative 4. That's our answer. Let's take a look at this for a second. So this inequality tells us that we could pick any number that's greater than negative 4, plug it into this equation, or this inequality, and it would work out. So let's pick a number greater than negative 4. I'm going to pick 1, because 1 is greater than negative 4. Well, 5 times 1 is greater than negative 20. Notice how this is the same equation that we had up here. I just put 1 in for x. Well, 5 times 1 is just 5. Keep our greater than sign, bring down our negative 20. Is 5 greater than negative 20? Yes, it is. So that's how we know that 5 is a solution for this inequality. So again, inequalities are just saying that you have multiple different solutions that are possible. Right? Number 4, any number you could think of that's greater than negative 4 would work out. We could pick 1,000,006, and that would work out in this problem. Last but not least, number 5, x divided by negative 4 is less than 12. Well, the opposite of dividing by negative 4 is multiplying by negative 4. So I'm going to go ahead and multiply both sides by negative 4. Well, multiply by negative 4, divide by negative 4 just eliminates to 1. So we're left with our x. 12 times negative 4 is negative 48. And if we go back up for a second, looking at our comparison, we said that the only difference is that if you multiply or divide by a negative number, your sign flips. So when we're looking at number 5, notice how we multiplied by this negative 4. So we started with a less than sign, but for our rules of solving inequalities, that sign will flip to a greater than sign. So x can be any number that is greater than negative 48, and that is our solution for this inequality. For inequalities, remember, same rules of solving equations. You're still isolating x, you're still using those inverse operations, but if you multiply or divide by a negative number, then your sign will flip.